So, as you have already seen the title of the video, that in this particular video, we will be solving the questions of limits which came in JEE Advanced 2024. So, this is our first question, and it is basically a question of limits and differential equation mixed. And what the question basically says, we will be reading it out. So, let fx be a continuously differentiable function on the interval 0 to infinity such that f of 1 is equals to 2, f of 1 is equals to 2, and we are given this particular limit for each x greater than 0, and then for all x greater than 0 we basically need to find this function fx. Okay, now if I look at this particular limit, and my first observation here is that the variable here is basically t, not x. Okay, since t is tending towards x, so the function fx in the first part, x to the power 10 in the second part, and t to the power 9, sorry, x to the power 9 in the denominator are basically constants. Okay, so let's move on. And if you put t as x in the numerator and denominator, you will be finding out that 0 by 0 form is going to be valid, and we can apply L'Hospital's rule. So without wasting any further time, let's begin. Limit t tends to x, and I'm just applying L hospital. So 10 t to the power 9 fx minus x is constant, and we will be differentiating f of t with respect to t, and in the denominator there is t to the power 9, that is 9 t to the power 8, and x to the power 9 is constant, so I'm not going to write it. So if you put t as x in the numerator and denominator, you will be finding out that specifically in the denominator, if I say t as x, it is not going to be 0, because if you look here carefully, that we are going to find this limit for x greater than 0. So here 0 by 0 form is not anymore valid, and so I'm not going to differentiate this anymore. So putting t as x, 10 x to the power 9 fx, I'm just breaking this into two parts, minus x to the power 10 by 9 x to the power 8 f dashed x, okay, is equals to 1. Now if I say that let fx is equals to y, okay, so I can cut this off, and in the numerator the power of x is going to be 1, and here the power of x is going to be 2. Now replacing this fx with y, 10xy by 9 minus x square dy by dx, x square dy by dx by 9 is equals to 1. So let's multiply both the sides with 9, and hence here it will be 9. Now what we need to do is that we need to divide both the sides by minus of x square, so that we can bring this down to linear form, and the coefficient of dy by dx is equals to 1, minus 10x by 10x into y by x square minus of 9 by x square. Okay, so dy by dx minus of 10y by x minus of 9 by x square. Now integrating factor here, it is going to be e to the power integral p dx. Now what is p here? Minus of 10 by x dx. So it is going to be e to the power minus of 10 ln x, that is x to the power of minus 10. Now we are going to multiply both the sides of this expression with x to the power minus 10, and on doing so we will be getting this minus of 9 by x to the power of 12. Now on integrating both the sides, what we can do, just a minute, minus of 9 by x to the power 12 dx y into x to the power of minus 10 minus of 9 x to the power of minus 12 plus 1 by minus 11 plus c. So here in this question we are also given one more thing that you can use, that is f of 1 is equals to 2. We must use it to find the value of c. So f of 1, that is x is equals to 1 and y is equals to 2. So f of 1 is equals to 2 means y is equals to 2 and x is equals to 1, and 9 by 11 into x, sorry, into 1 only, and c. So 2 minus 9 by 11, it is basically going to be 22 minus 9, that is 13 by 11 is equals to c, right? So our final expression, if I try to write from here, y equals 9 by 11 x plus 13 by 11 into x to the power 10. So is any option matching? 9 by 11 x, once again 9 by 11x plus 13 by 11 x to the power 10. So option B is the correct answer. So in this particular question, which came in JEE Advanced 2024 paper 2, we need to find the value of k, where we are given this limit, which is basically equals to e to the power 6, and k is something which is a number which belongs to the real number set. Okay, now let's look here. Limit x tends to 0 plus sine of sine kx plus cos x plus x whole to the power of 2 by x. Now if I put x as 0 plus delta in place of x, in, sorry, this is x as 0 plus delta in place of x, and we know delta is something which is very much close to 0, right? Which is very much close to 0 and it tends to 0 from the positive side of the number line. So sine of k delta is going to be 0, and sine of 0 we know it is 0, and cos of 0 plus delta is going to be, if I put delta, and as delta is tending to 0, then it is going to be 1, and x which is equals to 0 plus delta and delta is tending to 0, that is going to be 0, and in the power of this particular base we have 2 by x, that is if I put again x as 0 plus delta, it is going to be this 1 to the power infinity. Therefore, this particular limit is of the form 1 to the power infinity. And we know for this kind of, for the limits of this particular format, we have to take log of this function which is given here. That is entirely this function, we need to take log of it. So if I do that, that is, if I take this particular function as L, initialize this as L, sine of sine kx plus cos x plus x whole to the power of 2 by x, and if I apply log on both the sides, log of L is equals to 2 by x into log of sine of sine kx plus cos x plus x. Now and in the next step, if I apply limit x tends to 0 plus limit x tends to 0 plus. Okay, so as you can see, this is going to be 1 if I put x as 0 plus here, and 2 by 0 plus delta, it is also going to be 0. So here we have this 0 by 0 form, which is pretty important right over here. And you can also see that here in the left hand side there is no x present, therefore I can write it directly as log of L, and I can put this to outside of this particular limit x tends to 0 plus, therefore, and in the numerator I'm going to differentiate it with respect to x, 1 by sine kx plus cos x प्लस एक्स, साइन का डेरिवेटिव होगा कॉस ऑफ साइन के एक्स इंटू साइंस डेरिवेटिव इज बेसिकली कॉस ऑफ के एक्स इंटू के माइनस साइन ऑफ एक्स plus 1. Now if I apply x as 0 plus delta in the denominator, it is going to be 1, and in the numerator, if you look carefully, in the numerator if you look carefully, this sine of kx is going to be 0, and therefore cos 0 is basically 1, and again cos of k into 0 plus delta, where delta is tending to 0, is going to be 1. So I am getting here k sine of 0 plus delta is going to be 0 plus 1. Now there is an important thing, that here I have written this L is equals to this, and log of L, here this limit is basically equals to this, right? Now we are getting what I'm telling you, that we are getting log of L is equals to 2 times of k plus 1, right? Um, Therefore L is equals to e to the power of 2k plus 1. Now for your own clarity, I am doing one more step, that is I am putting limit x tends to 0 plus L. Why L? Because if I replace this L with this particular expression that is given on the right hand side, we are getting this, and whose value is basically equals to e to the power x, right? Whose value is basically equals to e to the power x. So this is equals to e to the power x, and here there is no x present, so therefore I can write directly L is equals to e to the power 6, and which is basically equals to e to the power of 2k plus 1. Therefore, if I compare both the powers, therefore k plus 1 is equals to 3. Therefore, k is equals to 2. So, our answer is basically k is equals to 2. So, in this particular question, we are given a limit whose value is basically equals to 0, and we have to find the values of alpha and beta. Um, this is a question of, as you can see from here also, that it is a multiple option correct kind of question, and it is a better question than the previous two questions that we did in the video so far. So let's start analyzing the question. I have written this limit over here, and so let's start now. Before moving any further, sine of x square, if I put x as infinity here, it is going to give me a value between -1 to 1. Okay, now log of x, where x is tending to infinity, is basically infinity, and sine of 1 by x square is going to be sine of 0, that is it is going to be 0. And if it is actually alone 0, then we cannot be actually be able to comment on the values of alpha and beta. Okay, if it is only 0, if it is at first hand coming 0, we won't be able to comment on the values of alpha and beta, and therefore we must first try to make adjust this first. because without adjusting this we won't be able to calculate the values of alpha and beta. So how I'm going to adjust it? I am going to just uh, in the denominator write 1 by x square, and here I am going to adjust it with x square. Why I am doing this? Because here 1 by infinity, here it is also coming 1 by infinity the whole square, that is going to be 0, and here it is also going to be 0. And we know, when just according to the standard limit, sine x by x is basically equals to 1. Okay, so what I can do is that I can just simply replace the sine of 1 by x square divided by 1 by x square as 1. Okay, so I'm doing just that only. Just give me a minute. This is going to be beta. What is happening here? Okay, this 1 by x square I must remove. Okay, and this x square, whatever I have written here, I am writing it along with this x of alpha plus beta. Okay, that is x of alpha beta plus 2. Okay, now you also need to understand that log of 1 plus x, when I'm putting x as infinity, it is also going to give me the value infinity. So these two functions, that is log x and log of 1 plus x, are nearly the same. So what I can do from here is I can write it just like log of x alpha minus beta divided by x of alpha beta plus 2. Okay, and we don't need to worry about actually the sign of x square, because it is going to give me a finite value anything between -1 to 1, the closed interval. So what I am doing here is I am just putting the values of alpha and beta given here and checking which are the correct options. Okay, now first of all we have this alpha is equals to -1 and beta is equals to 3, right? So in the numerator, you can check that ln x is basically equals to -4, and in the denominator, x, which is -3 plus 2, that is -1. So if I write it something like, it will be something like this: log of x to the power 4. Now, when x is tending to infinity, the value of x is much bigger than log of x. Okay, whole to the power 4. So this is not going to be actually 0. It is basically going to be infinity. It is basically going to be infinity, because the value of x, when x is tending to infinity, even though it has single power, then ln x, which has the power of 4, it is not going to be, it is going to be less. That is log of x is log of x whole to the power 4 is going to be much less than the value of x when x is tending to infinity. Okay, so our first option, we cannot choose that. This is a very, very important observation or inference that you need to understand. Next, if I put alpha as -1 and beta as 1, so log of x, that is alpha -1 beta -1 -2 by x, beta alpha into beta, that is -1 plus 2, that is 1. Now 1 by x log of x whole to the power 2. So as I said previously, that when x is tending to infinity, the value of log x is very much less, okay, than the value of x. So when x is tending to infinity, 1 by infinity is basically equals to 0, and this log of x is not even is not that big. So it is going to give me the value 0. So option 2 will be correct. Now, if I put alpha as 1 and beta as -1, so what am I going to get? I am going to get log of x as the whole square and divided by x -1 plus 2, that is 1. So log of x, when x is tending to infinity, it is very small. Okay, and 1 by x is tending to infinity, so 1 by infinity is basically equals to 0. So option 2, 3, sorry, option C is also correct. Now, here, as you can see in the fourth option, we have alpha as 1 and beta as minus of 2. So on putting in this particular limit the values of alpha and beta, we will be getting log of x as 1 minus a minus 2, that is going to be plus 3 in the power, and in the denominator it is going to be x minus 2 plus 2, that is going to be 0, that is going to be 1. So on putting x as infinity in this uh, expression, it will not be tending towards 0, it will be tending towards a bigger number, that is towards infinity. So the fourth option is basically incorrect. Thank you.